Let us understand about fundamental theorem of arithmetic. Before going to that, let us recollect factor tree. Let us recollect about factor tree. Example, consider a number 32760 is the given number. Let us factorize this with 2. 2 ones are 2, again 1 and 2, 2 6 are 12, and here 7 is there, 2 3s are 6, 1 and 6, 2 8s are 16, 0. So 16380. 2 into 16380 is equal to 32760. Now again factorize this 16380. 2 into 2 8s are 16, 2 1s are 2, here 1 8, 2 9s are 18 and 0. 8190. 2 into 8190. Again this can be factorized with 2. 2 4s are 8. 1 9 is there here. So 2 9s are 18. 0. 2 5s are 10. So 4095 here. Now this is 9 plus 4 13 plus 5 18 divisible with 3. 3 1s are 3 and 1 0. 3 3s are 9. 1 9. 3 6s are 18. 1 5. 3 5s are 15. 3 5s are 15. This value is now 1365. Let us factorize this with 3. 3 4s are 12. 1 6. 3 5s are 15. Again 1 5. 3 5s are 15. 3 5s are 15. So again this one let us factorize with 5. 5 9s are 45. 5 1s are 5. 91. Let us factorize this with 7. 7 1s are 7. 2 1. 7 3s are 21. 7 13s are 91. You can observe this factor tree. So 3 2 3 2 7 6 0 is equal to, how many 2's are there here? 1 2 3. So 2 cube into how many 3's? 2. 3 square into 5 into 7 into 13. 5 into 7 into 13. So this is equal to this. So this 32760 is factorized. These are the factors of this 32760 number. For example, if we decide that these factors are in the ascending order, means like small to big, 2, next 3, next 5, 7, 13. This arrangement is unique. This arrangement is unique for this number. If this order is not fixed, we can write it in any order, because this 2 can be there first or this 2 can be there at the last also. The same number 32760 can be written as, first we can write 3 square, then 2 cube, then into 5, into 7, into 13, into 13. Here this 2 and 3 places are changed, 0. So these are the factors of this particular number. Arrangement can be in any order. These factors can be arranged in any order, but the result is same. From this factor tree, what we understand that this number is equal to this. These are all called prime factors because this particular factor cannot be factorized further. This 2 cannot be factorized further. this 2 cannot be. Similarly here, similarly this 3 cannot be factorized further. This 3 is also cannot be factorized further. This 5 cannot be factorized further. This 7, this 13, all these are actually cannot be factorized further. So these are called prime factors. So this number is equal to product of primes. This number is known as composite number. This number is known as composite number. So what we understand from this factor tree? Composite number is equal to product of primes. Composite number is equal to product of primes. So this is nothing but fundamental theorem of arithmetic. Let us understand that. Let us recollect the concept of LCM. Concept of LCM. For example, given numbers are 12 and 18. LCM stands for least common multiple. Least common multiple. To get here, we have to get the multiples of this number. You might have studied in lower classes. So 12 multiples. Multiples in the sense like multiply with 1, 2, 3, 4, 5 and so on. 12 into 1, which is equal to 12. 12 twos are 24 into here. 12 threes are 38. 12 fives are 60 and so on. Now for 18. 18 ones are 18. 18 twos are 36. 18 threes are 54. 18 fours are 72. 18 fives are 90 and so on. So here you can observe this is multiple of 12. 12 into 1. Again this is also multiple of 12. See here, by observing the 12 multiples, here we have the multiple 36 where we are getting first time. In the sense, this is known as least common multiple. Why it is known as common? This is common for 12 and 18. So multiple of 12 is also 36. Multiple of 18 is also 36, which is common for 12 and 18. So this LCM of 12 and 18 is equal to 36. Is equal to 36. This method you might have studied in lower classes. Now let us understand about fundamental theorem of arithmetic. Here we are. Let us consider two numbers 12 and 18. 12 and 18. As we know, 12 can be written as 2 into 2 into 3. 2 into 2 into 3. 18 can be written as 2 into 3 into 3. 2 into 3 into 3. From factorization, we can get this. We can factorize 12 to get this and factorize 18 to get this. What this states for? Every composite number can be expressed or factorized as a product of primes. This 12 is a composite number. 12 is a composite number. And here 2, 2, 3, these are primes. Here 18 is composite number. This 2, 3, 3, these are primes. And this factorization is unique apart from the order in which the prime factors occur. Here this order can be changed. Here first place 3 can be there and at last 2 can be there, or the same can be written as 3 into 2 into 2. Here the same can be written as 3 into 3 into 2. Again this can be arranged as 2 into 3 into 2. Here whatever the order doesn't matter. Either 3 is there at first place or at the middle place or at the last place. by multiplying these factors, we have to get 12. So here, this means, what this mean? Apart from the order in which the prime factors occur. So here, whatever the order, we have to get back this 12. If this order is fixed, you have to get in ascending order only. If that kind of conditions are there, then that is unique. Then that is unique. So this is known as fundamental theorem of arithmetic. So in words, what we can say, composite number. Composite number, composite number is equal to product of primes. Product of primes. So this is fundamental theorem of arithmetic. This is also known as unique factorization theorem. Unique factorization theorem, and also known as prime factorization theorem. Prime factorization theorem. Now let us understand how we can get LCM and HCF by using this theorem. For example, we can consider this 12 and 18. 12 is factorized. So we can write 12 is equal to 2 square into 3. 2 square into 3. 18 is equal to 2 into 3 square. 2 into 3 square. Now, how can I get the LCM? LCM is equal to least common multiple. So here 1, 2 is there, here 2 are there. We have to consider maximum power. We have to consider maximum power 2 square, because this 1, 2 is already covered in this 2 square. And again here 3 is there, but here 3 square is there. So we have to consider maximum power 3 square. So this 3 is already covered in this 3 square. Apart from this, if we have any other numbers, those numbers also we have to include. For example, here only 5 is there, here 7 is there. We have to include 5 and 7 also. So now in this particular case, LCM is equal to 2 square 4 and 3 square is 9. So 9 into 4, 36. LCM is equal to 36. What is HCF? HCF is equal to, HCF is also known as GCD. HCF is also known as GCD. GCD means greatest common divisor. HCF means highest common factor. HCF is nothing but it is a factor. HCF is nothing but it is a factor. It is the highest factor. That means with that number, the given numbers can be divided with remainder 0. That is the highest number where we can have to get the remainder as 0. Highest common factor or greatest common divisor. So here for this same numbers we can consider for 12 and 18. Which should be common? So here 2 is there, 1, 2. And here also we have 1, 2. Here also we have 1, 2. And here also we have 1, 2. Now here 2 is there, but here in 18 we don't have. Here 1, 3 is there, and here also we have 1, 3. In 18 another 3 is there, but in case of 12 we don't have another 3. So which are all common, they are only we have to consider to get the HCF. So HCF is equal to 2 into 3, which is equal to 6. 2 into 3, which is equal to 6. So HCF is equal to 6. LCM is equal to 36. So while calculating LCM, we have to consider maximum powers. Maximum powers. While calculating the HCF, we have to consider minimum powers which are common for this 12 and 18, or which are common for the given numbers. Now let us understand this in the form of statement. Product of this, product of the smallest power of each common prime factor in the numbers, which is equal to HCF, highest common factor, or this is also known as GCD, greatest common divisor, and the product of the greatest power of each prime factor involved in the numbers, which is equal to LCM, which is equal to LC. So these are the statements. GCD or HCF is equal to product of the smallest powers of each common prime factor in the numbers. LCM is product of the greatest power of each prime factor. So now the numbers we considered here are 12 and 18. 12 and 18. We came to know that LCM of 12 and 18 is equal to 36. HCF of 12 and 18 is equal to 6. From this LCM and HCF and from the given numbers, we can come to a conclusion that product of the numbers is equal to LCM into HCF. Here 36 into 6, LCM into HCF. LCM is 36 into 6, which is equal to 12 into 18. This is equal to, here this value 6 6 are 36, 6 3s are 18 plus 3 20. This value is also equal to 216. 12 8s are 96, 96, 12 1s are 12 plus 9 is 21, 216. So this is also equal to 216. So now what we can understand from this, LCM and HCF is equal to product of the numbers. Product of the numbers. We can write in the form of AB. LCM of numbers A and B into HCF of numbers A and B is equal to A into B is equal to A into B. LCM and HCF is equal to product of that numbers. Given numbers are 1296 and 25. 1296 and 2520. Let us factorize this. Let us factorize 1296. 1296. 2 6s are 12, 2 4s are 8, 1 6, 2 8s are 16. 2 3s are 2 2s are 2 4s are 2 1s are 2, 2 6 are 12 and 2 2s are 4. Again 2 8 1. Again here 81 is there as 3 2s are 6, 3 7s are 21. 3 9s are 27. 3 3s are 9 and 3 1s are 3. Now let us factorize this. 2520. 2520. 2 1s are 2, 2 2s are 4, 1 2, 2 6s are 12 and 0. 2 6 are 2 6 are 12, 2 3s are 6, 0. 2 3s are 6, 2 1s are 2, 1 0, 2 5s are 10. 3 1s are 3, 3 5s are 15. As 15 is 2-digit number, we have to put 0. Again 3 3s are 9, 1 5, 3 5s are 15, 5 7s are 35. 7 ones are 7. Now this 1296 is equal to what? And 2520. 2520 is equal to what? 1296 case, how many 2's we have? 1, 2, 3, 4 2's. 2 power 4 into how many 3's we have? 4. So 2 power 4 into 3 power 4. In case of 2520, how many 2's we have? 3. 2 cube into 3's are 2. 3 square into 1 5 and 1 7. 1 5 and 1 7. Now what are the HCF and LCM? HCF is equal to highest common factor, where we have to consider the minimum power. So here 2 cube is there, 2 power 4 is there. So common is 2 cube. 2 cube is common for this and this. Here extra 2 is there, but which is not here. Here 3 square is there. This 3 square is also part of this. Here extra 2 3's are there, but in this number they are not there. So here what we have to consider? 3 square, which is equal to 8 into 9, which is equal to 72. So HCF is equal to 72. What is LCM? LCM is equal to, now to get the LCM we have to consider the maximum power. So here 2 power 4 is there, we have to get 2 power 4 into, here 3 power 4 is there, we have to get 3 power 4 into, now this 2 cube is part of this 2 power 4. 3 square is already covered here in this 3 power 4, into 5 and into 7 are left over. This is equal to 45360. 45360. What we have to do to get this? 2 4 times, 3 4 times into 5 into 7. So here 2 into 2 into 2 into 3, 2 into 2 into 3 into 3 into 3 into 3 into 5 into 7 we have to do. So to get this 45360. So this is equal to LCM. So now LCM is equal to this. LCM of 1296 comma 2520 is equal to 45360. HCF of 1296 2520 is equal to 72. Is equal to 72. We understand that to get the LCM, what we have to do? To get the LCM, we have to consider the maximum power, and to get the HCF, we have to consider the minimum power. Theorem of arithmetic. What fundamental theorem of arithmetic says? Composite number is equal to product of primes. So one number is equal to product of primes. We have to do factorization. By factorization, we can calculate the LCM and HCF. This is how we can get LCM and HCF by using fundamental theorem of arithmetic.